Alright, on this video I'm going to be going over simplifying polynomials. First up is addition and subtraction on these first two examples. So when you are adding or subtracting polynomials, you're only going to combine the like terms. So 8x to the fourth actually has nothing to combine with over here. So 8x to the fourth will stay as such. Now I will look for anything being cubed. There's nothing over here, but there is a 3x cubed over here, so it's going to stay positive 3x cubed. And now here comes a like term. 2x squared plus negative 5x squared will be negative 3x squared when we add those together. Now look for anything x to the first power. Nothing on this left one, but there is 7x over here, so plus 7x. And now add any constants together. So negative 1 plus positive 1 would be plus 0. So I'm not actually going to even bother writing that. And this is my final answer on example 1. So example 2 actually follows suit. What I usually suggest doing is actually changing any subtraction problem to an addition problem. So I would have 5x to the 6th minus 2x to the 4th plus 9x cubed plus 2x minus 4 being added to, now I will just negate every value. I'm distributing negative 1 here. So negative 7x to the 5th plus 8x to the 4th, because negative 1 times negative 8 would be positive, minus 2x, and plus 11. Now I'm going to go through the same process I did on example 1, where I just simply combine like terms. 5x to the 6th has nothing to combine with. Now we'll look for anything to the 5th power. Nothing over here, but we do have a minus 7x to the 5th power. We'll combine our x to the 4th powers. Negative 2 plus 8 is positive 6, x to the 4th power. 9x cubed has nothing to combine with, so positive 9x cubed still. Look for anything squared. There's actually nothing squared in either expression, so that stays away. 2x plus negative 2x will cancel to 0, so I don't even need to write that. Negative 4 plus 11 is positive 7. Just a quick note here about degree and number of terms. This polynomial would be of the 6th degree. You'll go with the highest exponent that you see there. And it would be said to have 5 terms in it. Now we're getting into the multiplication of all these. So on this first multiplication problem, all I got to do is just distribute. Reminder, your coefficients will multiply, but when you multiply like bases, like x to the 5th times x to the 3rd, that is where you would need to remember that you're going to add the exponents together. So negative 4 times 11 is negative 44. X to the 5th times x to the 3rd is x to the 5 plus 3 makes for the 8th power. And the reason why that is because exponents already represent repeated multiplication. Negative 4 times 2 is negative 8. X to the 5th times x squared is x to the 7th power. Negative 4 times 9 is negative 36. X to the 5th times x is actually to the 1st power here, so 5 plus 1 will make x to the 6th power. And on the last term, negative 4 times 1 is negative 4. X to the 5th is actually going with x to the 0 power, even though it's not written there. So 5 plus 0 is x to the 5th power. Pretty straightforward problem so far. Nice thing is, really no work to show here. So where this amps up is right here. I've actually got to distribute 2 times. Alright, so I'm going to distribute 3x squared x and negative 2 into this. So 3x squared is going to multiply the negative 4x squared minus 2x minus 1. Then x is also going to multiply it. And finally, negative 2 will also be multiplying it. Now, there are methods to representing this process, but it boils down to that right there, that you're going to, what I did was I distributed this trinomial to each of these first three terms, or you could have done it the other way around. Now, we distribute again. This is called double distribution. All right, so now I'm going to start distributing through here, just the way I did on the last problem, where I'm still adding my exponents together. I did make a little mistake here that x times negative 4x squared would be minus 4x cubed, but I just put plus a negative, which will be fine. That'll clear up in the next step. And here I'm just distributing by negative 2 on each of these. Now I've got a lot of like terms to combine. There is nothing to the fourth power except for this leading coefficient that I already have here, so I'm just going to leave it. I do have negative 6x cubed minus 4x cubed. That's going to make for minus 10x cubed. I do have three terms that are squared. Negative 3x squared minus 2x squared plus 8x squared. That's going to make for positive 3x squared, combining the coefficients there. Negative 3 minus 2 plus 8. And then to x to the first power, I only have minus x plus 4x. Again, this is minus 1x right there. So that's actually going to be plus 3x. And then plus 2 at the end as a constant, had nothing to combine with, and I'm done with that one. Alright, so we're going to rock this problem out. First thing you do is pick two of the binomials and multiply them together while keeping the other one outside for a moment. So I'm going to multiply these two binomials together into this set of parentheses, and I will still have the 3x plus 4 left to multiply there. Multiplying these two out, 2x times x will be 2x squared. 2x times negative 2 will be negative 4x. 5 times x. 5 times negative 2. Now I do have like terms to combine here before I move on, so I'm going to make that 2x squared plus 1x minus 10, and I'm still going to have to multiply that with the 3x plus 4. So much like on the last problem, I'm just going to take this 3x plus 4 and distribute it to each of these. So it's going to be 2x squared times 3x plus 4, going to be positive x times 3x plus 4, and it's going to be negative 10 times 3x plus 4. Now I have to distribute yet again. So I'm going to have 6x to the third. 2 times 3 is 6. X squared times x to the first makes x to the third. 2x squared times 4 is 8x squared. X times 3x is 3x squared. X times 4 is positive 4x. Negative 10 times 3x is negative 30x, and negative 10 times 4 is negative 40. Combine my like terms, I'm going to be done. So 6x cubed had nothing to combine with, but the x squareds will combine to 11x squared. 4x minus 30x will be negative 26x, and minus 40, the constant, had nothing to combine with. So this is a cubic because it's to the third degree and it's got 4 terms. Alright, now I talked about this in class, but just as a reminder, when you have a binomial being raised by the third power, please do not just simply raise each term by the third power and call it a day. What you have to do is you do have to multiply the 4n minus 3 to itself 3 times because it was to the third power. Now, if you were in my honors class, we talked about Pascal's triangle with binomial expansion, so you could go that route here. For my non-honors class, let's just rock this out. Very similar here, so what I'm going to do is just pause this and get to the end and then show what I did. Alright, you can pause this to catch up with all my work that I did, but I multiplied the first two pairs of binomials together, combined the like terms, multiplied the 4n to all three to get that, multiplied the negative 3 times all three to get this, and then combined like terms to get my final answer. Now, if you are not in my honors section, you're going to stop right here. You don't need to see the last example. If you're in honors, keep watching. So for my honors, I talked about Pascal's triangle to do binomial expansion. So that's what I'm going to do here, where I'm just going to really quick make Pascal's triangle out to the side here. If you have a power of 0, it's 1, power of 1, it's 1 and 1, power of 2, 1 plus 1 is 2, 1, power of 3, 1 plus 2 is 3, 2 plus 1 is 3, 1, power of 4, still not there, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1, and here we go, power of 5, 1 plus 4 is 5, 4 plus 6 is 10, 10, 5, 1. This right here is what I'm going to use for Pascal's triangle. Now my A term is C, my B term is -4. So let's go ahead and plug everything in. So 1 from right here times C will be to the 5th power, and -4 will be to the 0 power, plus 5 times C will be to the 4th power, -4 will be to the 1st power, plus 10, C will be to the 3rd power, -4 will be to the 2nd power, plus 10 again, C will be to the 2nd power, -4 will be to the 3rd power. Remember that the C's exponents are going down from 5, the -4's exponents are going up from 0. Now I'm at the 5 plus 5 times C will be to the 1st power, -4 will be to the 4th power, and here's our last one with the 1 as a coefficient, plus 1 times C will be to the 0 power, meaning it will go away, times -4 raised to the 5th power. And while that looks horrible, it is less work than going the other route. So now over here, 1 times C to the 5th times -4 to the 0. -4 to the 0 just goes away. 1 you don't have to write, so C to the 5th is my first term. Plus 5 times C to the 4th times -4 to the 1st. -4 to the 1st is -4. -4 times 5 is -20. And I would have C to the 4th power. 10 times C cubed, -4 squared. -4 squared is 16. 16 times 10 is positive 160. C will be to the 3rd power. -4 to the 3rd power will be -64. -64 times 10 is -640. C will be squared. -4 to the 4th power will be 256. 256 times 5 is 1,280. By the way, this will be positive. So positive 1,280. And C will be to the 1st power. And at the very end, -4 to the 5th power is 1,024, and it's negative, by the way, -1,024 times 1 is -1,024. C is to the 0, so you would not write it, and there is my answer. How lovely is that? Thanks for watching. Let me know if you need any help.